Hey guys, let's do lesson 2-3, solving multi-step equations. And the title is the same thing as the objective here, so to solve multi-step equations in one variable. Let's look at the getting ready box here on page 94. This is an example of how we're going to make multi-step equations. So you are buying movie tickets online for a group of your friends. You have to enter the number of tickets you want on the screen shown. You are using a debit card to pay for the tickets and have a total of $45 to spend. How many tickets can you buy? Explain your answer. So this might be a good time to just think about what I showed you in the last video when you make these equations, that the total is going to equal how you get total, or some form of that. I mean, I know we can switch the two sides around, but at least we know that you have a total of $45 to spend. So at least we have the total side is $45. And then it says how many tickets can you buy. So let's squeeze this in there. If it says how many tickets, we want to put T is going to be our variable, and T is going to stand for tickets. Okay, so let's see. Ticket price is $9. So there's $9, and each ticket is $9. So we have 9 times the number of tickets. Plus then you're going to have a $1 processing fee on each ticket. So now I have 1 times however many tickets I get, plus just a $5 service charge. And all of that together is going to add up to be $45. Now, see here how what makes this a multi-step equation is you have 9t plus 1t. So we're going to have to combine like terms before we can solve the equation. So this is going to become 45 equals 10t plus 5. And now it's just a two-step equation, so subtract 5 from both sides. 40 equals 10t, divide both sides by 10, and 4 equals t. So how many tickets can you buy? You can buy 4 tickets. So the new thing here is just we're going to be adding in combining like terms in the distributive property into solving equations. Alright, so problem 1, here's one where we have to do combining like terms. So what's the solution of 5 equals 5m minus 23 plus 2m? Before your goal is to get it to a two-step equation. So to get it to a two-step equation, you have to combine the 5m and the 2m. So if we do that, we have 5 equals 5m plus 2m would be 7m minus 23, and then solve the two-step equation. Add 23 to both sides. Oops, 23. 5 plus 23 would be 28 equals 7m. Divide both sides by 7, and 4 equals m. So just make sure you combine like terms, because again, at the end we're going to divide by 7. If we haven't combined the 5 and the 2, then we would be dividing by 5, and then we would be dividing by 2, which is wrong. So we want to combine them together, so we only have to divide by 7. Okay, got it. Number 1. What is the solution of each equation? Check your answer. So we will check our answer for the first one here. So notice how, the first thing you should do is figure out where your variables are, because that's going to tell you if you need to combine like terms or not. So here we have 11m, and then we have minus 6m. So 11m minus 6m would be 5m minus 8 equals 22. And then we have a two-step equation, so add 8 to both sides. We have 5m equals 30, and divide both sides by 5. I'll put it over here. M is going to equal 6. Okay, so m equals 6 is the answer. Let's check that. So if we had 11 times 6 minus 8 minus 6 times 6, that should equal 22. And for the sake of time, we could put this all in the calculator. 66 minus 8 minus 36. I'm pretty sure it's going to equal 22. If you want to put it in your calculator, you can, but it should equal 22. Okay, and part B. So variables here, we have minus 2y, and we have plus 5y. So negative 2 plus positive 5 is going to be 3y, plus 5 equals 14. Subtract 5 from both sides. I'm going to put that over here. So I have 3y equals 14 minus 5 is 9. Divide both sides by 3. And I have y equals 3. So your answer for part B is y equals 3. And if you wanted to check your answer, you could always plug 3 back in. So, I mean, if you have extra time on your tests, I would encourage you, if you get y equals 3, to plug it back in, because then you're going to know whether you're right or you're wrong. If both sides, when you plug 3 back in, you get 14, then obviously you know you have the right answer. Okay, so let's write an equation for this one. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. So I have two different things here. I have t-shirts and bumper stickers. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts and no bumper stickers. If Martha's total is $67, what's the cost of 1 shirt? So here's what we want our variable to be. We'll say, what's the cost of 1 shirt? We'll say that S is going to stand for cost of shirt. And again, if we use that same kind of like guideline, total equals how you got the total. Here's your total, $67. Now, how did we come up with that total? So let's go back to the beginning. She buys t-shirts and bumper stickers. So the bumper stickers cost $1. So you know how much the bumper stickers cost, but you don't know how much the t-shirts cost. So Martha's niece wants 1 shirt. Okay, so that's going to be an S. Plus 4 bumper stickers. But you know each bumper sticker costs $1. So we can really just add on $4 for the 4 bumper stickers. Her nephew wants 2 shirts. So we need to add on 2S for her nephew and no bumper stickers. So we don't have to add anything else. Now, if we go through and we combine like terms, if we combine the S's, we have 67 equals, so altogether she's buying 3 shirts. 2 for the nephew and 1 for the niece. So 3 shirts plus $4 in bumper stickers. If we solve this for S, it'll tell us the cost of 1 shirt. So subtract 4 from both sides. We have 63 equals 3S. Divide both sides by 3. And we have S equals 21. So that's pretty expensive, but what's the cost of the shirt? $21. Now, I mean, since this is a word problem, you could probably say $21 is the cost of a shirt, or 1 shirt costs $21. Okay, I got it too. So it says Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys two packs of strings in a music book. So again, we have different things here. We have strings and we have music book. But it tells you how much the book costs. The book is $16. Their total was $72. How much is 1 pack of strings? So let's say P stands for pack of strings. And again, the total was $72. So the $72 equals, how did we come up with the $72? So reread the problem. Noah buys 2 packs of strings. So that's 2S. Kate buys 2 packs of strings. So that's plus another 2S. And a music book, but it tells you the cost of the book is $16, so we can just add on $16. Eventually, we're going to get to equations where you have to figure out the cost of the strings and the cost of the music book. But because we're just practicing this in one variable for now, they have to tell you the cost of the book in order for you to be able to solve the problem. So combine like terms. We have 72 is going to equal 2S plus 2S would be 4S plus 16. Solve the two-step equation. Subtract 16 from both sides. Let's see. I don't have a calculator, so I'm going to make this 12, make this 6. 56 equals 4S. I'll put that over here. 56 equals 4S. Divide both sides by 4. And we have S equals $14. 56 divided by 4 would be $14. So when you have to put this answer in to your quiz, you can just put that the answer is right here, $14. How much is 1 pack of strings? $14. Okay, next part is if you have the distributive property within the equation. So you want to make sure what's the solution of -8 and then in parentheses 2x minus 1 equals 36. You don't have to do the distributive property first. there's going to be a problem later on where I'll show you a different way, but for now, let's go ahead and do the distributive property. So negative 8 times negative 2x is negative 16x. Negative 8 times negative 1 is 8, so I'm going to write plus 8 equals 36. And then this is a two-step equation, so subtract 8 from both sides. We have minus 16x equals 28. And now when we divide both sides by negative 16, this is negative 28 divided by negative 16 doesn't work out equally, so let's just leave this as a fraction. It's going to be a positive divided by a negative, so the answer is going to be negative. And we know we can divide them both by 4, so if you divide 28 and 16 both by 4, you get 7 over 4. So the answer is x equals negative 7 over 4. So got it number 3. It says, what's the solution of 18 equals 3, parentheses, 2x minus 6. So do the distributive property first. So we have 18 equals 6x minus 18. Then we want to add 18 to both sides because now we just have a two-step equation. 18 plus 18 is 36 equals 6x. Divide both sides by 6, and we get x equals 6. So your answer to got it number 3, part A, is x equals 6. Now part B says, can you solve the equation in part A using the division property of equality instead of the distributive property of equality? Well, the division property just means if you can divide both sides by 3. Well, the division property is whatever you do to one side, you have to do the other, and you can use division. So see how this is 3 times this whole quantity? You can almost think of this as 18 equals 3x, and x is just actually represented by what's in the parentheses. So if it was 18 equals 3x, we would just divide both sides by 3. Well, we can still divide both sides by 3, and the 3 and the 3's cancel out. So now we're going to have 6 equals 2x minus 6, and we could just solve from there. Add 6 to both sides. 12 equals 2x. Divide both sides by 2, and you still get x equals 6. So, yeah, I mean, it's up to you whether you want to go through and do the distributive property, or if you just want to right off the bat divide both sides by 3, and then you have a two-step equation. I think this second way is probably easier, just dividing both sides by 3, but as the problems get more complicated, you have to be careful, because if there was another piece to this, if let's say this was 18 equals 3, parentheses, 2x minus 6, and then it had plus something else, you want to divide everything by 3, you would also have to divide that other piece by 3, and in that case, it's probably better to do the distributive property. But if you just have an equation where all you have is 3 times something, then you can choose. Either way, it's probably the same amount of work either way. It's just a matter of if you feel comfortable with the distributive property or not. Okay, now here's probably the hardest part of this chapter, is when you have these equations that involve fractions. There's two ways to do this. Obviously, if you have fractions, you have to go through and you have to get common denominators. So if you look at this problem, 3x over 4 minus x over 3 equals 10. You could go through and you could get the common denominators of 12 and you could do all the math. You can look at that in the book. It's on page 96. But there's an easier way to do this, which is what I'm going to show you. It's just method 2, is if you just clear out the fractions. So to clear out the fractions, you're just going to multiply by whatever the common denominator would be. So if you look at the 4 and the 3, the common denominator would be 12. So I'm going to, now remember, you have to multiply both sides by 12. So if I multiply this side by 12, 12 times 10, that's 120. That's the easy side. Now, if I'm going to break this, I'm actually going to distribute here on this first one to show you here. If I do 12, then I'm going to have 3x over 4, and then I'm going to have minus 12 times x over 3. All I did was just do the distributive property. So now, when I do 12 times 3x over 4, see how 12 and 4, that can be simplified. They both share a common factor of 4. So divide them both by 4. The bottom, 4 divided by 4 is just 1. And the top is going to be 12 divided by 4 is going to be 3. So all I really have now, instead of 12 times 3x over 4, the 4 canceled out, so I don't really need to divide by 1. I really just have 3 times 3x, which is 9x. And over here, the 12 and the 3 both share a common factor of 3. So 3 divided by 3 is 1, which is good. That's going to get rid of the bottom. And 12 divided by 3 is 4. So now instead of 12 times x over 3, I just have 4 times x, which is minus 4x. And that's going to equal 120. And now I just combine like terms. So I completely eliminated all of my denominators, and I just have 9x minus 4x. So that's going to be 5x equals 120. And then if I divide both sides by 5, I'm going to get x equals 24. Okay, and this is definitely something we'll practice a lot in class, getting rid of these fractions, because this can be pretty tough. Alright, so let's try these got it number 4s. Again, think about what the common denominator would be. So if I make this one bigger here, if I rewrite this as 2b over 5 plus 3b over 4 equals 3. If I multiply both sides by the least common multiple, which would be 20, I can clear out the fractions. Okay, so 3 times 20 on the right side, that's just going to be 60. Okay, so what I'm going to have is 20 times 2b over 5 plus 20 times 3b over 4. I just distributed the 20 into both terms. And now simplify. The whole reason you're multiplying by 20 is to get rid of the denominators. 20 and 5 share a common factor of 5. So 20 divided by 5 is 4, and 5 divided by 5 is 1. So now all I have is 4 times 2b, which is going to be 8b. Then over here, 20 and 4 have a common factor of 4. So divide both by 4. And 5 times 3b is 15b equals 60. And then if I loop this over and do the rest over here, 8b plus 15b is going to be 23b equals 60. And to finish solving this, we would just divide both sides by 23. Now, that's an improper fraction. So, well, 23 divided by 3, 23 cancels out. 23 is going to go into 60 2 times. And 2 times 23 is going to get me to 46. Then from 46 to 60, I need 14 over 23 more. So b equals 2 and 14 over 23. Okay, let's try part B. Okay, we have 1/9 equals 5 over 6 minus m over 3. Now, this one is different than the last one, because in the last two, whatever it equaled wasn't actually a fraction itself. But now, what it's equaling, so now instead of just worrying about the two denominators on the other side of the equal sign, we actually have to come up with a multiple of 9, 6, and 3, because we need to clear out the 9 as well. So the least common multiple between 9, 6, and 3 is going to be 18. So we're going to multiply both sides by 18. Okay, so 18 times 1 over 9, they share a common factor of 9, so this is just going to be 2. 18 divided by 9 is 2, so 2 times 1 is 2. Now, as you get better at this, you're going to be able to do this in your head. Think about if I distribute this 18 times 5 over 6. The 18 over the 6, the 18 is going to become what? 18 divided by 6 is going to be 3. So into this first one, all I'm really distributing is 3, because it's divided by 6. 18 divided by 6 is 3. So for the first part, 5 times 3 is going to be 15. For the second part, 18 divided by 3 is 6. So what I'm really distributing here is a 6. So minus 6 times m is going to be minus 6m. And then you just finish and you solve the two-step equation. So let's subtract 15 from both sides. We have negative 13 equals negative 6m. I'm going to loop this over to here. Negative 13 equals negative 6m. Divide both sides by negative 6. And again, this is an improper fraction. That's not going to work out to be a nice number, but we do know that a negative divided by a negative is going to be a positive. 6 goes into 13 2 times, and that gets you to 12, and then we have 1/6 left over. So the answer there is going to be 2 1/6. And the last part, this is probably the least important of all. What's the solution of 3.5 minus 0.02x equals 1.24? I'll show you how to clear out the decimals just so you know, but most likely you're going to have a calculator, so you could really just do all this in your calculator. But I'll show you. If we have 3.5 minus 0.02x equals 1.24. Just like we were trying to clear out the fractions, now we're trying to clear out the decimals. So if you wanted to get these all to be whole numbers, the smallest one is 0.02. If we multiply that by 100, it would move the decimal point 2 places, and we would have a whole number. So what we're going to do is we're going to multiply both sides by 100, and that's going to clear out the decimals. So 3.5 times 100, if you move the decimal place 2 times, that's going to be 350 minus 0.02 times 100 is going to be 2x, and that's going to equal 1.24 times 100 is 124. So, I mean, you could finish solving this equation, but when you do, you end up getting x equals 113. And again, this isn't a big of a deal because we could just use a calculator. And so for got it number 5, you need to look at your decimal that goes to the most amount of decimal places, which would be this one in the middle. So in order to get 2.325 to a whole number, we would have to multiply it by 1,000. So we're going to take both sides. Oh, that had an X on it. Equals, and we're going to multiply them by 1,000. So this side times 1,000, this side times 1,000. 0.5 times 1,000 would be 500x. And now this is going to become a whole number. 2325 equals 3950. And when you end up solving this one, you get x equals, 12.55. Again, not a big deal because you could just put the decimals in your calculator. So the main things here was make sure you combine like terms, and make sure you do the distributive property if you need to. And that's it.